Hi, I'm Ed Carmack. In the last session we talked about the ODS database and how it differs from Colleague. So let's finish up our introduction to ODS report writing by reviewing some key database concepts and terminology. Speaking of terminology, as I was preparing this presentation, I happened to be using an iPhone app called Dragon, which is a voice-to-text converter. It takes dictation and converts it to text. Sometimes what it hears isn't what I meant, because whenever I say ODS, Dragon translates it as odious. And so far as Dragon is concerned, this is an introduction to ODS report writing. I hope none of you will find report writing odious. Personally, I think it's challenging and often fun. Anyway, please remember to set your viewer to full screen so that you can read the slides, and print out the handout listed for this topic from the training website if you haven't done that. We'll be continuing on page 2 of that handout. This list of terms dealing with the hierarchy of data is one that I'm sure many of you are familiar with already, but let's just review it so that we're all on the same page. A database is a collection of files that we'll call tables. Each table is a collection of records concerning a single topic, such as a course or student, faculty member, and so forth. Tables are often interrelated, as we've seen. For instance, students take courses, so the courses table and the students table are related. A record is a collection of data fields describing a single instance in a table, such as a single student or a single course. And a record corresponds to a row in a table. A row is a collection of data fields, and a data field is a collection of characters, with character being a single symbol or a letter or a digit. A data field is an individual item of information in a record, such as a first name or last name or telephone number. Data fields are also called data elements or data items. In this illustration, the database is symbolized by a cylinder because it's a container which holds a number of different files or tables. The tables in this database are named students, courses, advisors, and so on. An individual table is composed of rows and columns. The columns represent the individual data items like last name, first name, telephone number, and the rows represent individual records. If the table on the right were a student table, row 1 would be student number 1, row 2 would be student number 2, and so forth. Every table has at least one data field that functions as that table's key. The key is a data field that contains a unique value for each record in the table. It enables us to select any single row in a table by specifying the key's value for its row. And as you'll see, it allows us to link related records in two different tables. As you should already know, the person ID data field is the primary key for the person table. Its value must be unique for each record in that table. We also have the concept of a foreign key, which is a data field in one table that contains the primary key for another table. And we'll see how that works shortly. Here we see two tables that are related to one another. The ODS person table has the colleague ID as its primary key, and the ODS applicants table has the applicant ID as its primary key. Although these key data fields have different names, the values stored in them are identical for related records. In other words, these two tables are joined based upon the key fields. In this illustration, the information in the applicants table for applicant number 2 pertains to the same individual in the person table for the record with ID number 2. So to select information on the same individual from two different tables, we match or join the records based upon the key data field. As you can see, the person table contains one record for each individual in the ODS database, but it contains demographic information only. The applicants table contains one record for each applicant in the ODS, but contains applicant-related information only. It contains no demographic data. In order to retrieve the demographic data for applicants, the two tables must be joined so that we retrieve information from matching records only. When joining these two tables, we must know how many matching records will be retrieved from the applicants table for each record we select from the person table, and vice versa. In this example, a record in the person table might have 0 matching records in the applicant table because not all individuals in ODS are or have been applicant. Many individuals are faculty or employees. But a record in the person table might also have several records in the applicants table if they had applied for admission several times, maybe as undergrads, as master's students, as specialists, or even doctoral students. Also, for every record in the applicants table, we must find exactly one matching record in the person table, because we know that every individual and colleague must have a record in the person table. The point is that in report writing, you will need to have a good understanding of the relationships that exist between the tables that you're working with. So this gives us the background that we need in order to write a database query. Now, a database query is a statement that you're going to write that can be executed by the system and that specifies which data fields you want to extract from the database tables or tables. A query specifies the data field names that you want to retrieve, the table names that contain the fields, and also how the records are to be joined if more than one table is involved. Here's an example of the kind of thing you'll be learning to do in future sessions. Suppose I want to create a report that lists the applicant's ID, the admissions representative, the first and last names of the applicant, and the gender for all the applicants that we have on file. Well, first I need to determine the ODS field names and table names that I want to extract. In this case, I want the applicant ID and the admissions rep, which will come from the ODS applicants table. And I want the first name, the last name, and the gender that will come from the ODS students table. I also determine that the records in these two tables are joined based upon the ID. Once this query has been input to the system and executed, which we'll be learning to do shortly, then this illustration shows the results of that query. So we can see that we have all those data fields that we specified for all the records that are in the ODS at this time. So we see at the top of the illustration, we see the two tables joined on the ID, and then we see the results of the query, which will be the applicant's ID, the admissions rep, first and last name of the applicant, and the gender. And once we have this data extracted from the database, we can easily save it to an Excel spreadsheet on your computer, and then you can use that data to create a report. In future lessons, we're going to focus on query writing and the use of specific report writing tools like Excel and Access and others as we find necessary. Well, this concludes our introduction to ODS report writing. In our next lesson, we'll be looking at connecting our desktop computer to our data source, that is to our ODS database, and then we'll start looking at actual query writing using Microsoft Excel.